Ladies and gentlemen, welcome back. My name's Jeremy Champa. We're going to be looking at practice test 6, and we're going to be looking at the non-calculator section. And I'm going to start on number 6. Before I do, remember, the whole idea here is to use these videos to help you understand questions that you've already worked on. So if you haven't worked on the questions from this section yet, at least do each question before you look at the explanation, right? So if you want to do number 6 now and then watch the video, great. But make sure you're looking at the questions and doing the work first. The reason that the questions aren't appearing on the screen is because I want you to be active in the way that you use these videos. By that I mean to say, don't just sit back and watch the video. Open up the test, do the work, then watch the video while looking. Have the test either in front of you on a piece of paper or on the screen as well, so that you can see the actual question. Be as active as you can with this work. Don't just sit back and let it wash over you, because that's no way to actually get better at something. You have to be active. Okay, so number 6, which says x is equal to 2/3 y, and y is 18. So, by the way, that y should be here, not in the denominator. Y is 18. So look, this is a trap where I feel like there's probably an answer for just like what x is, right? Because the move would be to put 18 in the place of y. And remember, when you multiply a fraction times just a number, it's really like 2 times 18 over 3 times 1. So that would be equal to what, 36 over 3, which is equal to 12. X is 12, but that's not the right answer, because they want to know what 2x minus 3 equals. So x is 12, but 2x minus 3 would be 24 minus 3, or 21. Right? So that was a situation where, look, there's the two strategies that we try to use over and over again, which are using real numbers, either from the problem, like we have a is 21, b is 15, and so on, or picking our own numbers, but we can't really pick our own numbers. They've dictated what y is. It's 18. It means x is a fixed number. It's 2/3 of 18. We can't pick our own numbers here, and really there's no easy way to use the answer choices. To be clear, you could use the answers still. And if you use the answers, you start with the middle numbers. Let's pretend I started with b. 15. If you say 15 is equal to 2x minus 3, you add 3 to each side, which means 18 equals 2x. You divide by 2, and you would say x is 9. And then you would see if that works up here. Well, if x is 9, 9 equals 2/3 of y, and you would have to solve for that. You would say, well, one thing you can do to get rid of a fraction is multiply by the reciprocal. That's because 2/3 times 3 over 2 is equal to 6 over 6, or just 1. So you get rid of that fraction by multiplying by the reciprocal. And if you did that, you'd get 27 over 2, 9 times 3 over 2. And that's not big enough. 27 over 2 is 13.5. We're looking for y to be equal to 18. We'd know we'd go to a bigger number, and I would be done that way. Right? So I need a bigger number for 2x minus 3 so that y is a bigger number. So you could use the answer choices here. You could do that. But to me, it's the same work as just doing the question straight up the normal way. So 2 approaches, either the normal approach or using the answer choices. Notice if you use the answer choices, you start with the middle number. Obviously there's no middle number here because there's 2 answers in the middle, right? It's either B or C though. When you start in the middle, you can get rid of 2 answer choices more quickly. Like, because I knew 15 was too small, I actually knew all 3 of the other answers were wrong. That's how I got A. Right? If 15 worked, perfect, I'm done. If 15 was too big, well, I'd have to try out answer choice C, which is 12. And after I figured out that was, if that was too big, then I'd know it was D without doing any more work. Right? So the idea of using the answer choices is to cut down on the amount of work you're doing. So start in the middle. Okay. So I hope that was clear. Feel free to watch it again. Feel free to leave a message with me and let me know how I can improve my explanation of that and help you out a little bit more. Okay, so number 7. This question it has variables in the answers. That's where I'm starting. That means I can pick my own numbers if I want, I think, usually. As long as they make sense for the variables. But look, actually there's something else I'm noticing here. So I go to the last sentence. That's where I always start. I don't read the story they give me. I just go to the last sentence. And the last sentence says L in terms of N and H. N and H. It's a weird and sign. N and H. My H's look like K's. Sorry. But that's what the question asks. And really, that means something very simple. It means get L by itself. So I'm just going to take what they've given me, N equals 7LH. And I'll, if this is all multiplication, right? This is 7 times L times H. Well, then divide by 7. And then divide by H. So it would be like N over, usually we write 7H, not H7. N over 7H. And that would be your answer. Look, I didn't have to read their silly story because there was an equation and they told me something very simple. Get L by itself. What is L in terms of N and H? Be ready for that game. Every time they say get something in terms of something else, it just means get it by itself. Here's the other way to look at number 7, just to be clear. You could pick numbers here. Make them easy numbers like L is a 2. Right, I'll write this like L times H, and then I'll write, well, if L is 2, and let's make H like 3, then we have 7 times 2 times 3, that's 14 times 3 is 42. So now we have numbers that I've picked. This was the way I was talking about up front at the beginning. So which one works? You try out A. A would say, the L value of 2 is equal to 7 divided by N, which is 42, times 8, which is 3. Look, you can tell that's wrong because this is not, we have to get 2. This is smaller than 1. 7 divided by a big number. You don't have to do the math. Doesn't work. So then you go, okay, well, what about answer choice B? Well, that says our L value of 2 is equal to 3 divided by some other big numbers. I'll just write 3 divided by big, right? It's 42 times 7. So no, can't be right. You try out C. C, which I think we figured out was the right answer before. N is 42 divided by 7 times H. 7 times H is 7 times 3. Yeah, that's 42 over 21. That totally works. And you got to try out the other answers just to make sure, especially when, if you've used a 1 or a 0, you would definitely have to do this. But you can see that it's wrong, answer choice D, pretty quickly. 2, does that equal 42 over 7 plus H, which is just 7 plus 3 or 10? 42 over 10 is not a whole number, right? It's 4 and 2/10 or 1/5, 4.2. So that's out. That's the other way to do number 7. And you can do this anytime you have variables in your answer choices. This is a good bet that you could, I can't say every time, but most times. All right, so number 8. This question, for which value x is wx plus tx equal to x? The big thing I'm going to highlight here, look, when you do a question, if you know what the most likely mistake is when you start the question, you're most likely to avoid that mistake. So what's the most likely mistake that I notice here? Well, mixing up x and y's. What I call x, y confusion. Just mixing up x's and y's. So let's break this into pieces. What is wx? Well, that's a y value. That's a y value. And t of x is also a y value. We want this to be equal to x. Well, look, let's just use the answer choices. So let's start, and I'll do the same thing. Sometimes you don't know if starting in the middle is gonna help or not, but you just try it to begin with. So let's try this x equals 2 thing. Well, what's w of 2? W of 2 plus t of 2, does that equal 2? Well, w of 2 is positive 3. right? You figure out what is the W value when x is 2. You follow the graph over and you get 3. What is t of 2? Well, when x is 2, t is -1. I got so lucky. That's the right answer. But you could try out the other values too. I'll just try out one more just to show you. So C says 3 equals x. Well, that would mean W of 3 plus T of 3, in order for this to be right, would have to be equal to the x value, which is 3. I know that's confusing. Break it into pieces, though. W of 3, T of 3 equals x. So x is, in this case, 3. What's W of 3? Well, when x is 3, W is 4. When x is 3, T is 1. And 4 plus 1 does not equal 3. So that's... You wouldn't know to go bigger or smaller there necessarily, because it doesn't tell me that these equations are linear, and in fact, they don't look linear. Why do I know they're not linear? Because they don't increase by the same amount each time. Notice what happens to W of x. You go from -1 to 3, a distance of 4, but then you go from 3 to 4, a distance of 1, and then 4 to 3, a distance of 1, and then 3 to -1, a distance of 4. So that's a parabola, because we see the growth is symmetrical on each side. The vertex would be here. The vertex of Wx would be 4, because you'll notice that, x equals 3, y equals 4. At x equals 3, if you go 1 unit to the left or right, you go down 1 in either case, right? So at 2, x equals 2, you've gone down 1. At x equals 4, you've gone down 1 from the high point at x equals 3, which is y equals 4. So hopefully that's not too confusing. It doesn't matter, really, so I'm not going to continue on that. But essentially, just to finish up here, if this is the top, which is 3, 4, what I'm noticing is we have like 2, 3, and we have 4, 3, and then we get it to be steeper. So I'm drawing this poorly, but then you have 1, -1, and 5, -1. So I'm seeing that symmetry, which lets me know that W of x is a parabola, which doesn't matter. The only reason I brought it up is because when you have not a line, you can't say, oh, go bigger or smaller, go to, if one of these is wrong, go to the other one. You wouldn't know that, but you could just try out answers. So I think that's really the best way to do number 8. Okay, number 9. Flag the easy mistake at the beginning. What's the easy mistake on number 9? The difference between this and this. X and the square root of x. Which one are we talking about? And do the simple work first, right? Like, okay, look. Square root of 9, square root of 64. We know what those things mean. That's 3, and that's 8. If you're confused about square roots, there's plenty of help. I would just go to Khan Academy or something. But I'm going to move forward as if we know what roots are. 9, the square root of 9 is 3. The square root of 64 is 8. Now I just subtract 3 from both sides, and I get the square root of x is 5. That does not mean x is 5. We have to square both sides. Square a square root is the same thing as those things cancel. It's like multiplication and division, or add and subtract. Square and square root. So this is just x. That's the point. That was why we did it. We're trying to solve for x. And then 5 squared is 25. So flag the easy mistake at the beginning. Don't mix up 5 and 25. I mean, look at the answer choices. They tell you that that's the thing, right? You have root 5, and then 5, and then 25. They're messing with the idea of roots and square roots. So be careful with that stuff. No, and look, sometimes we all say stuff like be careful, and I don't think be careful is the best descriptor of good advice. Yes, be careful, but take an active approach to noticing and mitigating errors. Mitigating means lessen. So, or, manage the downsides of something. So mitigate the damage by saying, what do the answer choices tell me about the easy and most common mistake for everyone? Okay. moving on here to number 10. 10 is a good one. So what 10 is doing is showing you some unorthodox ways of thinking about averages. Right? Here's what I would probably start with on this question. You start with the last sentence, no matter what. Anytime you have a paragraph like that, start with the last sentence. We want to know the number of miles X he could bicycle on the 4th week to meet his goal. So I know what X is. X is miles the 4th week. Just write something down like that, miles in 4th week. You underline it on the test or something, whatever you want to do. Okay, well, look, he wants to average 280. Seems like he's doing a pretty good job because he's got like 240, 310, and 320. And he wants to average 280. Notice I'm not writing equations, I'm just writing information down. So he's doing pretty good. I mean, you could say, probably a number just below 280 because you have these couple that are above 280 and this one that's below. So probably, something close to 280 would be a good number to just try out. But really what I would do is I wouldn't try to create an equation that matches the answers here. What I would do is use this interesting tool that I've learned about. I've heard them called tan charts. Total average number. Okay, well, here's what I know. I'm trying to average 280. I'm trying to ride for 4 weeks. I'll multiply these two numbers to get the top. So here's how it works. We usually say total. We add everything up. We divide by the number of things. And that gives us our average. What I'm saying is that could work in reverse. Right? To be clear, what I just said is total divided by number equals average. Well, if you multiplied both sides by number, by n, cancel here, and you say the total equals the average times the number. So if you know two parts of this chart, you can always figure out the third by multiplication or division. The average times the number will give you the total. There's two ways of calculating totals. Add everything up or multiply average times number. We can't add everything up because we don't know what everything is. We know what 3 of the things are, but not all 4, and that'll come in handy in a second. Well, what's 280 times 4? Use your calculator for that, but that's, I believe, 1120. Right? That's 800 plus another 320. Okay, so I need to get 1120. This is what I have so far. These 3 things, those add up to what? 320 and 310 is 630. And then 670 and then 870. I think I did that right. You would use your calculator for that, but that's 630, 830, 870. Notice how I'm breaking it in pieces. That's how I do my mental math. But now the difference is the amount we have to ride in the 4th week. This is so far in 3 weeks, 870, and this is after 4 weeks, the total. So what's the difference between those? Well, it's 250? So you would find an answer that works with 250. I guess that's kind of a long approach, right? But if you don't see the answer in an obvious way, that's what you should do. The other thing is, like I said, if you have a general sense of what you're going for, so I'm saying I think my answer, I'll write it up here, is 250, and I would be looking for an answer that works that way. But I just want to show you what the right answer ends up doing and notice what the wrong answers do as well. Like the traditional approach to an average question is you would say take each week 240 plus 310 plus 320 plus x the 4th week divided by 4, and that should equal 280. Look what answer choice D does. It says all that same stuff, but it multiplied both sides by 4. So if you multiply 4 over 1 times all this stuff, the 4 cancels, and you would have 4 times this stuff. So 4 times 280. That's answer choice D. That's what they're doing here. Let's recognize what each of the mistakes, what each of the other answer choices do. So A is wrong because it takes the average of the first 3 weeks. That's cool. But you have to average all 4 weeks. So you can't just like have the 4th week unaveraged and say that has to be bigger than or equal to 280. No. I ignored the greater than equal than sign, but like I'm not focusing my attention on that sign because all the signs say the same thing. It's all greater than or equal to something about 280 on the right side. So that's why A is wrong. B makes the mistake of not averaging anything at all. So that's why B is wrong. And then C is kind of the same mistake as A, only just slightly differently. I mean, look, you could say 240 over 4, 310 over 4, 320 over 4. But if you did, you would also have to say plus X over 4 is less than or greater than and equal to 280. But we don't have X over 4, we just have X, and that's why C is wrong. Okay, so that was pretty long-winded. To be clear, if you had this X equals 250 and you tried out the answers, this is the only one that would work. Pretty long approach to that question, though. It's definitely one in which if you notice something in the answer choices, you save yourself time. But here's the last thing I'll say about number 10. If you're just going to use the answer choices, if you do this, so if using answers, you must prove all others wrong. No assumptions. Don't assume you're just like, oh, I got the right answer, I'm good. Don't do that. I have bad handwriting, but you get my idea. I hope. Anyways, all right, let's move on. Here's number 11, which is a parabola question. Look, here's what we know about this is a question where you just want to know some stuff. Know some stuff. You're like, great. Well, I promise after this you'll know some stuff. If you have, this is vertex form of a parabola. Here's the rule. Like, just notice that if you did this math out, so if you FOILed this out and then you multiplied by negative a, you'd end up with negative ax squared. This means opens down. If it were positive, it would mean it opens up. That's the first thing. So you can now go to the answer choices and be like, it doesn't open up, so A is out and C is up. And then notice that no answer choice, this is a y value. This is the y value of the vertex in this case. So let me be clear about something here. If you had a different form, like if you had y equals, I'll write it out down here. If you had plus, well, no, I want to be careful. Let me write it over here because it's a different equation. But if you had what's called standard form, you have ax squared plus bx plus c. This is the y-intercept now, the c. Down here, this is the y value of vertex. So that's two different things. But either way, it's a positive C. And if you'll notice in the answer choices, answer choice B and D, there's no difference there. The only difference is what happens in parentheses. In parentheses, I just always want you to think about opposite sign. It's an easy way to remember that if you have a negative B here, then the point that you'll see on the graph is a positive B. Answer choice B has B comma C. Answer choice D is wrong because it has negative B comma C, and that's incorrect. Opposite sign. I see a minus B. I'm picking positive B. So, just to be clear, what I was saying down here opens downward. That applies up here as well. This A shows us if it opens up or down, and it has to do with the sign. It's the stuff in parentheses that's always the opposite of what you think it is in terms of sign. The stuff outside of parentheses is always pretty standard and normal. Okay. So here's what you're going to notice as we get to the end of this section. A lot of times people think, because the test is supposed to get harder as it goes, that if you're not doing extremely well, that the last few questions don't matter. But the thing is, a strategy that you can use on the last few questions can turn a lot of so-called hard questions into easy questions. So in number 12, I have variables in my answers, and I've already talked about this. But if I have variables in answers, I'm going to try to use numbers, use real numbers. Let's be total nerds and say x is 0. If x is 0, then 4x squared plus 6x over 4x plus 2. I'm just putting in an x equals 0. That's 0 plus 0 over 0 plus 2, which is equal to 0. Any answer that doesn't get me 0 is out. B is out. Let's see, what does C say? C says 0 minus 2 over 2, right? And that's equal to negative 1. Let's try out D. D says 0 plus 1 minus 2 over 2. Again, all I did in these answer choices is I put in x equals 0 everywhere I saw an x. Look, this is 1 minus 1, which is just 0. So I do have two answer choices that work when x is 0. So I'm going to keep going. Let me just show you what we've already got. We've got A, we crossed off B, we crossed off C, and we've got D. Just by picking out x is 0. Now I'm going to try out x is 1. X is 1. 4, 1 squared plus 6 times 1. What I'm doing is I'm putting in 1 for x in my original equation to see what I get. Well, what's that? 10 on top over 6, 10 sixths. Well, guess what's not 10 sixths? Answer choice A. So I'm done. It's D. I could solve it if you're uncomfortable with what we've done so far. 1 plus 1, x plus 1, so that's 2, minus 2 over, in this case, if an x is a 1, we have 4 times 1 plus 2, which is 6. Yeah, well, if you get a common denominator, this is 12 sixths minus 2 sixths, which is, 10 sixths. And of course, you could reduce it. You don't need to, though. So as questions get challenging in the non-calculator section, look to use real values to help you. And number 13 is a question you could do in the same way. It may be a little confusing, but not quite the same way. But what I mean is we have these answer choices, and they ask us what the value of t is. And they say, which one of these is t? Well, let's see. If let's try one of the middle numbers, and like this looks easy. Let's try t is 1. Okay, so then be 2 times 1 squared minus, oh, I'm sorry, I'm messing this up because I just thought these were x's. These are t values. Let me write that above the answers. These are t values. So there's this thing about not having any solutions. I'm going to show you another way in a second. But to start with, you could try out the numbers. 2x squared minus 4x equals t. Now I'm trying out t equals 1. Is there a way to get this? Now, look, it's not that easy to just we're looking to get no solutions. No solutions. No real solutions. It's not that easy to look at this and know what to do next. You could turn it into a parabola it already is a parabola on the left side, but subtract 1, set it equal to 0, and do some math. If you were to do that, what I would suggest doing, we want no real solutions. You could say what's not factorable is one way of saying that, but sometimes it's not that obvious what is and isn't factorable. But if you can see that, great. You could also use the quadratic formula. I know people are like, oh no. Here's what I'm going to do. I'm going to go to a generalized form and show you how to use the quadratic formula here. So let me back up. It was written originally like this. This whole thing is equal to t. Then I would, if I wanted to know no solutions in a traditional approach, I'd subtract t from both sides. And then look, here's the quadratic formula. I'll write it down here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. If that seems confusing to you, I would do some research, find out some more about what the quadratic formula means. But to be clear, when you've got stuff equal to 0, this is the standard form of a parabola. ax squared plus bx plus c. So that a is a 2, b is negative 4, and c is negative t. So you could just plug this stuff in. And I actually only care about one thing right now, which is this part. This part here. This is very important. This part tells you the number of solutions. If this thing is positive, there's 2 solutions. 2 solutions. If this thing is 0, there's 1 solution, and that's what we want. If this thing is negative, there is 0 solutions. Okay, so you just plug this stuff in. B squared, well, that's b is negative 4, so negative 4 squared minus 4. Be careful of signs here. Know that that's an issue and take active measures against it. A is a 2. C is negative t. That's the hard part of this question if you're doing it in a traditional way. And this is not the same 0, but we do want this to be equal. Oh, we want no solution, so we want this to be equal to a negative number. Negative number. I don't care what that negative number is. Okay, well, this is 16, and this is positive 8t, and we want this to be equal to a negative number. Well, you better make t a negative number that's big enough. So negative 1 would not be big enough, because then you would get 16 minus 8. So it must be negative 3. That's a standard approach using what's called the discriminant. This thing down here, this piece under the square root, discriminates. I'm not saying it's, this is something that's discriminating against people. What I mean to say is that the discriminant helps you determine or figure out how many solutions. That's what discriminate could also mean, is to tell the difference between. Discriminate between answers that have solutions or don't have solutions, and if they do have solutions, is it 1 or 2? So that's the standard approach using the discriminant. You get things in the standard form, which is how I subtracted I subtracted negative t. Subtracted t, got negative t. That was going from here to here, and then I just applied the discriminant. There is another way, and it's an important way. So hang on with me, because I promise this way's maybe even more important. Think about these as 2 separate graphs. Set equal to each other, because setting equal is intersections or solutions. So if you think about these as set them equal or solutions, here's what I know about 2x squared minus 4x. Go back to what we talked about earlier. This part tells you if it opens up or down. And then look, we have a plus 0 here. So that's the y-intercept. So here's what I know. I don't know how low this parabola goes. Now I could tell you, by the way, negative b over 2a, the other part of the quadratic, remember this part of the quadratic, this tells you the x-coordinate of the vertex. So you could figure that out pretty quickly. X-coordinate of the vertex. So the quadratic is really made up of 2 parts. The b squared minus 4ac we just talked about, and then this part, which is the x-coordinate of the vertex. I could figure that out. But even if I don't do that, here's what I know. It opens up. If it's here, or if it's here, or if it's here, it doesn't matter. It opens up. And y equals t is a horizontal line, because t is just some value. Well, let's try out the various values. We have y equals t. If t was equal to 3, that would be up here. So look, there's some parabola that's above that. No solutions means no intersections. The parabola I've drawn has 2 intersections. I don't know if that's the right parabola, but here's what I know. Because it opens up, I need to create a horizontal line below my parabola. Well, if only one answer is right on this test, the lowest number is what I'm going with. That is to say, look, here, I'll give you an example of what I'm talking about, because this is really powerful. I'll back up. Okay, so let's say that -1 also worked. Let's say that this was our parabola, and let's say that this is -1, and it crosses twice. Or even, crosses, if I wanted to, I could make it cross right at the bottom. Right? Let's say that's... Well, then, if it crossed... Well, I guess we want to know solutions, to be clear. Let's pretend, this is, y equals -1. Well, then y equals -3 would also have no solutions. There's no way to have two answers that work on a multiple choice test. So the lowest one must be right. It must be that the parabola does this or something. So I'm visualizing it as, whenever I think about solutions, just to be clear, solutions, intersections. So in this case, the parabola opens up. We must have a horizontal line below it. The lowest one must then be right. That's poorly written, but you know what I mean. That says, looks like it says lost with a W. What I meant is lowest. You get what I mean. Hopefully you get what I mean. If you don't get what I mean, well, you can do it in the traditional approach. But I really want to emphasize this idea that solutions mean intersections, and you can use estimation if you know that the parabola opens up and you're talking about a horizontal line. Well, then it better be a low line so that it never hits the parabola. If it's a line that's up high enough, it's going to hit the parabola somewhere, right? Because if it opens up, it goes forever. So even if you're way up here, technically that would hit it as the parabola went up further. Okay. I want to be clear on that one because I know it can be tricky to think about those concepts. But if nothing else, use the discriminant. All right, 14. Massive paragraphs start at the end. The last sentence doesn't tell us much. Which of the following systems of inequalities best represents this situation? What situation do you mean? Well, let's work backwards. It says let D represent detergent and S represent fabric softener. Number of containers. Go down to the answer choices and see what are your differences. So using the answers, we have 2D or 2S, 2D or 2S, or signs going one way. I guess the signs are all going the same way. Okay, so look, working backwards and using my answer choices. I know what D and S are. It's number of detergent containers and fabric softener containers. Let's just figure out what this 2S and 2D is. If you go to the sentence before the one we just read, it says the service wants to buy at least twice, two times as many D as S. Look, this is where the problem is. Anytime they say things about bigger, less, 2 times as big, this thing's 80 less than this other thing, be really, really careful. That's where the mistake is. And again, I keep saying be careful, but what I really mean is take an active approach against that. So tell yourself some numbers. It doesn't have to work for the whole situation. Just worry about one equation at a time. Break it into pieces. What is 2 times as many D as S? Okay, you could have D equals 100 and S equals 50. That's what we mean. And if you say at least as many, you could say S equals 49 or 8. Any number that's less, you want at least twice as many. If S is 50, you want at least 100D or 200D. I did it the other way where I said, if S is, if D is 100, you want half as much of that or a little bit less. I know that's confusing. That's the heart of this question. Find equations that make sense for this. So what we're trying to say is if D is 100, 50 is cool, 49 is cool, 8 is cool, 51 is not cool. The reason I'm saying that tangible is because I know how hard it is to just look at the equation and get it right. So look, answer choice, we can cross off some answers just based on that. I'll put A, B, C, and D up here. Answer choice A works because it proves that 100, if you put in 100 for D and 50 for S, it's cool. If you put in 100 for D and 49 for S, it's cool. Still works. You would be saying 100 is greater than, sorry, running out of space here. 100 is greater than, if you used 49, that would be 100 is greater than 98. Yes. And you also want 51 to not work. Well, that's perfect because 100 is not bigger than 102, which is 2 times 51. So A works, and C is the same thing. But B does not work. Let me explain to you why B doesn't work using real numbers. 200D would mean 2D would be 200. Yes, that is greater than 49 times 2 or 8 times 2. But it's also greater than 50, or I'm sorry, I messed that up. Let me back up here. I was right for the most part, but I said something silly. So if I'm looking at B, which says 2D, well, if D is 100, we're saying 200. Yes, it's greater than 49 or 8 or 50. But it's also greater than 51. We want this equation to not work for 51, right? 51 is not cool because the sentence said twice as many detergent as fabric softener. 100 is not at least twice as big as 51. So if that's confusing, I get it. Slow down. Think about what I've just said. Hopefully it'll help you. We can cross off B and D based on that. And look, the other half of this question is just, again, messing with this 2 times as many D. You still use the the weight per container, 7.35, to figure out the whole weight of the detergent containers. However many containers you have times the weight of one of them. That's C. The same way you say 6.2 is the weight of the fabric softener container, and you multiply that times the number of containers. You don't double the weight of each container just because you're getting twice as many containers. D is the value that tells you about how many containers you have. You simply multiply that by the weight per container. That's why C is out. But I'm telling you, for most folks, the big mistake has to do with this 2D versus 2S thing. That's the easy mistake. If you know from your study, when you do this work with me, if you learn about the easy mistake, you can avoid that mistake, and that's how you get more questions right. You don't get questions right by just getting smarter. It's not how it works. You get questions right because you've learned about the traps the test sets, and you perk up for those specific traps. Take active measures against the most common mistakes. So it's really easy to write 2D here, but that's not what we mean. We mean that softener is a smaller number, and it would need to get multiplied by 2 to even reach D. Right? If you have twice as many detergents as fabric softeners, you have 100 detergents, for instance, and 50 softeners, that's perfect. That's what we mean. D equals 2S. D is greater than or equal to 2S if we have at least as many. But use real numbers. Okay. Last question of the multiple choice, and then we'll talk about a few of the grid-ins. Here's 15. This is what I mean about using values. Let's just call it A. I don't want to call it a number in the problem, so I'm going to call A 3, and I'm going to call B... I don't want it to work out to... I don't want to call it 6 and then have B over 2 equal 3 as well, so I'm going to call B 8. So now we're asking what is 3 plus 8 over 2 squared. And you can, of course, do that math. That's 3 plus 4 squared, which is 7 squared, which is 49. I'm trying to get 49 when these answers, or when these values are present. And you might be like, that sounds like a lot of work. I get why you would think that, but all the terms get repeated. A squared is in every answer choice. That's 9. B squared, that's 64 over 2. Well, that's 9 plus 32. So no. 32 and 9 does not equal 49. It's close, but not quite. B is smaller. Look, what did I get here? I'll write it down. 32 and 9, so that's 41. Smaller is not going to do it. Why am I saying it's smaller? Because we were dividing by 4 instead of 2. Everything else is the same. C. Okay, well that's 9. AB over 2. AB is 3 times 8, which is 24 over 2. 24 over 2. And then B squared over 2. We already did that math, right? That was 32, right? It's 64 over 2, which is 32. That's too much. Why do I know it's too much? Well, 9 and 6 is 15. And 15 plus 32 is what? 40. Oh, it's not too much. It's too small. Okay, so it didn't work. Sorry, I was wrong. It wasn't too big. It was too small. We have 15 plus 32, which is equal to 47. Too small. So answer choice D. How do I know? Well, it's 9 plus AB, which is 24, and then plus 64 divided by 4. 64 divided by 4 is what? 16? And 16 and 24 is 40 plus 9 is 49. Perfect. That's the right answer. So that's using real numbers. Let's identify the most common trap for number 15. Most common trap is people just think a squared plus, here's what people think. They think you can just say a plus b over 2 squared. They think you can just distribute the squared and say a squared plus b over 2 squared, which is equal to a squared plus b squared over 4. Remember, when you square a fraction, b over 2 times b over 2, it's b over 4. So in order to really show you the mistake, let me show you what I mean. So a squared plus the way that you do, if this were true, and this isn't the right answer, but if it were true, you'd be saying b over 2 times b over 2, which is b squared over 4. So that's a squared plus b squared over 4. That's how people get answer choice B, which is the most common mistake. But the problem is you can't just distribute this. This is wrong. You can't do that. You have to multiply it by itself. The whole parenthetical phrase times itself. And then you do what's called FOIL. You multiply the first term, a times a squared. The outside term, well, here's the outside, that's a b over 2. You multiply the inside, a times b over 2 is ab over 2 again. And then lastly, b over 2 times b over 2, which is b squared over 4. Well, these two things in the middle, two groups of ab over 2, you could call that 2ab over 2, which is just ab. Right? Essentially, you have half AB and another half AB. So the in-between step would be to say this is two groups of AB over 2, and then these cancel, so you just get AB and then B squared over 4. That's the traditional approach. The mistake happens when people forget to FOIL because it's not written as A plus B over 2 times A plus B over 2. They just write squared. Means the same thing. Very easy to make a mistake there. Okay. So how do we avoid that mistake? Take active measures. One of two things, just to back up. One of two things. Use a real number or actually write out the fact that you're foiling instead of just looking at this and being like, oh, I think I know what to do. It's number 15. Even if you're brilliantly smart, which I'm sure you are. Sorry to be patronizing. I'm not messing around. However you're doing on this test, you have the ability to be an extremely brilliant person in the world because there are many ways to be brilliant. And school doesn't test all of them. So aside from putting my sarcasm aside, the truth is, no matter how smart you are, it's easy to make a mistake on this question. This question is not mathematically extremely complicated. It's a simple idea, roughly. I mean, for high school students, this isn't the hardest thing. It's very easy to get wrong. Be humble about that reality. Use that reality as a way to recognize the trap, or at least to take active measures to do things in an unorthodox way, do things differently than the average student. Will save you some hassle. Okay, so I'm going to breeze through. Actually, I think I'll do all of them here. Here's 16. It says a b over 4 equals 16. You can pick any numbers you want here. Look, I'm thinking about 16 as like, look, the easiest thing to do, make b 4. Then you have a to the 4 over 4 equals 16. You could have then a to the 1 equals 16. A is now equal to 16. That's totally cool. You could also have b be like an 8, and then you would have like, you know, a to the 8 over 4 equals 16, which means a to the 2 equals 16, which means a equals 4. Either of those is cool. You could do other stuff too, I'm sure. Maybe. But those are the two that came to my mind. I guess you could use a is 2 as well, and then you'd be saying 2 to the, what, 4th power, so then b would be a 16. You can do all sorts of stuff there. Just throw some numbers at it. Easiest way to do it. 17, 2/3 t equals 5 over 2. 5 over t. No, 5 over 2. Sorry. Okay, you have to... Look, some people will say divide by 3 and multiply by 2. Totally true. You could also just multiply by 3 over 2 because it cancels all this. You get 6 over 6 with t, which is just 1t. So you multiply both sides by 3 over 2. When you multiply fractions, it's straight across the top. 15 over 4. That's the easy mistake people make. It's not 15 over 2. It's 2 times 2 in the denominator. 5 times 3 over 2 times 2. Okay. Let me get access to some of these other questions. Oops, I messed up. Okay. Look, so number 18. This is a similar triangles question. What they want you to recognize is that if you have the same angles, I know that was not the best drawn triangle, I'm going to keep going though. If this is 8 and 6, what you have is this is a 3, 4, 5 times 2, right? So to be clear, 3, 4, 5s aren't just those single sets of dimensions. They could also be just 3 times something, 4 times something, and 5 times something. In this case, this is 3 times 2, 4 times 2, and 5 times 2. Once you know two sides of a right triangle, you can always figure out the third. So look, if this is 18, it's 3 times as big. So everything's 3 times as big. This is 30, and this is 24. Everything's 3 times as big as our 6, 8, 10. You could call this 3 times 6, 4 times 6, and 5 times 6. Now, the last trap, they didn't do it. Just be ready for them to ask about this length or this length here. DE or BA, AB. What they actually ask for is CE, though, which is actually kind of nice. They don't ask you some sneaky thing. CE is just 30. This idea of 3, 4, 5 triangles. Briefly, let's just talk about the triangles that matter on this test. I just mentioned 3, 4, 5. Let's do this. I'll be a little bit smaller so I have room for everything. So 3x, 4x, 5x. That means, like we just saw, 6, 8, 10, 18, 24, 30, 30, 40, 50, whatever you want. You could also have, not drawn to scale because I'm not the best artist here, you could have 5x, 12x, 13x. So the way that will usually show up is 10, 5, 12, 13, or 10, 24, 26. Just multiplying these by something. So those are both called Pythagorean triples. They're super important. They come up a lot. Look out for them. The other two that come up a lot have to do more with the angles, although the sides are, of course, something we can figure out. If this is 30 and this is 60, then whatever you call this side, the short side, the one across from the 30, the one across from the 60 is that times root 3, and the hypotenuse of this 30, 60, 90 is 2x. That's super important. If you see root 3s showing up in answer choices or in questions, that's probably what they're talking about. By the way, this is half of a equilateral triangle, right? Because if this is 60 and this is 30, you have 60, 60, 60, and then these are all, x, x, 2x. So 30, 60, 90 is half of an equilateral. Important thing to know. The other one worth knowing is the 45, 45, 90. So let me draw that. Roughly like this. The sides are equal because the angles are equal, 45 and 45. the angle 90 here has x times root 2. So x root 2. So, by the way, that's half of a square where the sides are all just x. And then 90-degree angles got cut into two 45s, right? So if you see root 2s floating around, think about 45, 45, 90s. If you see squares, maybe cut it in half. It's a 45, 45, 90. The same way if you see an equilateral triangle, you cut it in half and make it a 30, 60, 90. Super important stuff. Those are the 30, 60, 90 and the 45, 45, 90 do appear at the beginning of the test. But important to know that stuff. Number 19. How many liters of this one solution? Okay, this is a challenging question. So I'm just going to show you the way I did it. I'm going to be honest with you about the way I did it the first time. The way I did it the first time is I just tried out 3 liters of each. Right? And so if you do 3 liters of 10% and you do an equal amount, 3 liters of 25%, then because you have equal amounts, the average would be halfway in between. So the average of 10 and 25, halfway in between those two, is 17.5. 6 total liters at 17.5%. Well, look, we wanted a 15% solution, so I want less liters. So the way I did it the first time, again, this isn't the way that, is the most practical, but look, you don't always know what you're going to do on this test, and I want to be honest with you about how to create progress when you don't know what else to do. What I did next is I tried out 2 because we don't have a calculator. So I just said 3 liters times my 10%. So you could write that as, to be clear, you could write that as maybe 3 times 0.10. And then I said, okay, 2 liters times 0.25. And I'm going to be honest with you, this is what happened. I was like, okay, well, give myself a little bit more space. Okay, this is 0.3, and then this is 0.5. And I'm like, I want that to equal 0.15. Obviously, it's not going to no matter what, because I'm not going to add a negative amount, and this part is fixed. It's 0.3. Oh, it's 0.15 times the total amount. So what's the total amount? Oh, 3 and 2, the total number of liters. Well, does this work? Just to be clear, this should be written as maybe does this equal 5 times 0.15? And it doesn't. This is equal to 0.8, and that does not equal 5 times 0.15, which is 0.75. So no, doesn't work. But I know I need less now. And look, it's the non-calculator section. So it's not going to be some crazy number. You could try out 1, see that that's too small, and then get 1.5. But what you should really do at this point is generalize this equation so you don't have to just keep plugging through. So you go, well, look, some unknown amount of the 0.25 could be written as x times 0.25. And the total is 3 plus x times the amount that, the stuff that we wanted. Running out of space again, sorry. Which would be 0.15. So that would be your equation. You'd say 0.30 plus 0.25x equals, you got to distribute this, which is 0.45 plus 0.15 times x. And then you could just do this math. Look, you could multiply everything by 100. 30 plus 25x. Get rid of these scary decimals without a calculator. And then you could finish. Subtract 15x. Maybe subtract 30. So we've canceled this out and this out by subtracting. Let me be clear. I subtracted 15x and I subtracted 30. So what does that give me? 10x equals 15. X equals 1.5, which makes sense. 1.5 liters. If 2 liters was too big, but by not much, it's 1.5 liters. No calculator section. That's pretty likely to happen. One more thing I want to show you about this question because it's super important. The way I just did it was hard, but here was the idea. roll up your sleeves, use some numbers that make some kind of sense. In this case, 3 was too big. Tried out 2, 2's too big. Go to a smaller number, or generalize the work you just did. The big idea that everyone mixes up is this total, this 3 plus x business. The total of the 3 liters you had and the unknown amount of liters that you're adding. Unknown is x. 3 plus x is the total. Okay, let me show you one other thing. Very, very useful with what you might call weighted averages. Here's 25% on one end of my spectrum of my number line, and here's another 10% at the other end of my number line. What we want to end up with is at 15%. Well, think about it like a game of tug of war. 10% is winning. This distance is 5. This distance is 10. So 10 is winning the tug of war. It's way closer. This is closer. Use more of the 10% to end up closer to the 10%. Use twice as much to get twice as close. That's what I've used in the future on these weighted average questions. And that sounds sneaky, but what I'm saying is 15% is twice the distance from 25 as it is from 10. Twice the distance. That means I need to use twice as much to the one it's closer to, or half as much of the 25. If I'm using 10% of, or if I'm using 3 liters of this stuff, I want to use half as much over here. That way, what we get is an amount that's way closer to 10% because I've used more. I've used more of the 10%, so I end up closer to the 10%. Use less of the 25%, so I end up further away from the 25%. Hopefully that's a helpful concept for you. Think about it. Last one is a circle question. Proportions. Everything's proportionate. Proportions. I'm not the best speller, which might be disconcerting. Anyways, here's what I mean. Segment area over total area equals arc length over circumference equals, the central angle over 360. All these things are proportionate. So what are we dealing with here? We're dealing with circumference and arc length stuff. So 2 pi r is 2 pi times 1. Arc length is pi over 3. Okay, you know what they're doing to us here? They're messing with us with these fractions. If you want, you could write it out like this. 1/3. If you want, just for the time being, write this as 0.33. We usually don't do decimals within fractions, but nobody's looking. That is to say, no one's grading the work that you've done. So 0.33 over 2. Okay, the pi's cancel. So pi over 3 is the same thing as 0.33 pi. That might help you, not make a mistake with fractions and within fractions. And then 0.33 over 2, you could write this as, 1/3 over 2, which is 1/6. Or you could say, like, how do I get from 0.33 over 2 to, what do we want to know? The fraction of the whole thing. Okay, yeah, so I would just say multiply both of these by 3. You get 1/6. However you get from here to here is cool. If some people are cool with 1/3 over 2 and realizing that means 1/6. Whatever it takes. Look, here's one other thing you could do. You could say 1/3 or 0.33. Instead of saying divided by 2, say multiply by 1/2. Right? So let me rewrite that. I could have written this part as pi times 1/3 divided by pi and times 1/2. Maybe that's more confusing. I don't know. 1/3 times 1/2 is 1/6. All right. So if stuff like that, the 1/3 multiply, what do I do with fractions? If that's getting in your way, I want you to use Khan Academy to strengthen those sort of foundational skills. The purpose of these videos is to help you understand strategy and concept on the SAT, not to walk through some of the more foundational skills that you need to make sure you can get this work done accurately. So if that kind of work is difficult for you, look, if you made a silly mistake, fine. Notice the silly mistake, take active measures like I just did by making it 0.33 over 2 and do whatever you got to do. But if the concept is confusing to you, go use Khan Academy because it does a great job dealing with concepts. I don't think it does as great a job dealing with strategy. And that's okay. That's why I've made these videos, to help you with strategy. So let me know if that's helpful. Anything that I've talked about today, let me know if something was unhelpful or confusing. Whatever feedback you have for me, I'd greatly take it. Gladly take it. Greatly, gladly, maybe both. Anyways. Until next time, happy studying, and I look forward to helping you again if you would like my help. Take care.